Greetings and welcome, friends. Mr. Waddy here. We're taking a look at last night's quest. We were solving systems of linear equations using the elimination method, and this time we had problems where we didn't have opposite coefficients, where our variables would not have been eliminated if we simply added them together right now, right? If I added those together, I'd have 12x. If I added these together, I'd have negative 8y, and neither of those variables are eliminated. So my goal in step one of the elimination method is to get opposite coefficients, one pair of those, sometimes it'll happen with both, so that when I add them together, they will in fact be eliminated. So before we do that, let's look at these x's, okay? And what is the least common multiple between 8 and 4? What's the smallest number that they would both divide in? So 2 goes into both of those. That would be a factor of those. And I know, like, that's actually hard for me to communicate precisely. So 2 is a factor of both of those. But when I'm talking about multiples, I'm saying, so 4 times, and then 4, 8, 12, 16, 20, and 24. These are multiples of 4. And multiples of 8 would be like 8, 16, 24, 32, etc. And I'm looking for the least common multiples. Since both of these lists have 16, but it's not the smallest of that list. And actually, I wouldn't be wrong if I used 16, or even like 32 shows up later on this list. I wouldn't be wrong. I still could get the right answer. I'd still eliminate variables. But the reason I'm choosing the least is because smaller numbers are easier to work with. Mathematicians are efficiently lazy people, and that's why I'd rather have small. So let's see. For the x's, the least common multiple would have been the 8. For the y's, what do both 3 and 5 go into? Write the list here just for our internet friends. Oh, I just skipped. Oh, there we go. 3, 6, 9, 12, 15. And let's try the 5's. 5, 10, 15. Counting by 5's. 20. Looks like 15 would be the least common multiple for that list. So, before I commit, now I'm looking at my two options here. I think I'm going to aim for 8 because, once again, smaller numbers are to work with. We'll get full credit, okay, if you got opposite y's. Like, I'm not going to tell you you're wrong. That's fine, okay? So just so you're aware, you don't have to go the most efficient path or the easiest path as long as you're obeying the laws of algebra. And if you took the scenic route and still got to the answer, I'm fine with that, as long as you're using elimination when I ask you to use the elimination method. So now the question is, what would I have to multiply this by in order to get 8? Well, this one's good, right? That equation already has an 8x, so I'm happy with that. What would I have to multiply this second equation by in order to get the 4 to be an 8? 2. And I'm shooting for opposite coefficients, and since this one's positive, I'll make this one negative, right? So that way they'll actually be opposite. So step 1, I'm multiplying, in this case, just one of my equations. Sometimes you have to multiply both. Like if I was going for opposite y's here, I actually would have had to multiply the top by 3 and the bottom by like negative 5. But in this case, hey, I only ended up having to multiply one of them. That's convenient. So let's multiply through by negative 2. So that would be negative 8x. Negative 2 times negative 3y is plus 6y. And negative 2 times 5 is negative 10. And I'm just going to rewrite this equation here, only so that when I'm doing step 2 and adding, I don't have to keep looking like, 2 rows above to see what I'm adding together, because it's super easy to accidentally add the thing from the wrong equation. So I'm gonna rewrite this. 8x minus 5y equals 11. All right, so step 2, we now add these together. This is where the elimination happens. This is where the magic happens, friends. And when I add these together, look at this. Beautiful. Negative 8x plus 8x is 0x, which is 0, which I don't even have to write. So those got eliminated, which is what I wanted to happen. 6y and negative 5y, add those together. That's just 1y. Let's just call that y, right? I like that. Equal sign, bringing it down. And negative 10 plus 11 is 1. Now, sometimes you have to solve for this remaining variable, but it actually was already solved for. So Step 3 is the solve part, and step 3 is done. Y equals 1. That's only half of our answer, though. We're looking for the XY combination that makes both of these equations true. And there's likely only going to be one of them. Today we'll consider some special cases. But what I can do is now substitute 1 for y. If those two things are truly equal, I can plug this into either equation I want. Is there any preference you guys have? Any of those equations you think will be easier to work with? The second equation, the one with the, or which one were you thinking? First equation or the second equation? Doesn't matter. You'll get the same answer either way. I'll plug it into this one, like, because these numbers kind of seem smaller. That's my only reason. Not wrong. Chose an alternate route. So let's see. So I'll have 4x minus 3. And instead of y, I'm writing 1. And that is equal to 5. So let's see. So I've got 4x minus 3 equals 5. And now we're solving, friends. How do I solve that for x? How do I get x by itself? It's being multiplied by 4, subtracted by 3. If I move first. Add 3, right? We SAD method, we reverse PEMDAS. Yeah, to each side in order to maintain equality, to maintain balance. Everybody gets added by 3. So let's see. So 4x equals 8. And then the inverse of multiplying by 4 is division by 4. And I'll get x equals 2. All right. So this is elimination method. My solution is the ordered pair 2, 1. You can check your answer. I'm not going to take the time to do that right now. But yeah, by plugging in 2 and 1 for the x's and y's, and they should work. They have to work for both of the equations. Now, why wouldn't I have wanted to use substitution on this set? Like, why would substitution have just been like, oh, man, this is going to be a lot of work? Does anyone know why? What do I like to have when I solve by substitution? Well, when I solve by substitution, if I was looking at this, I would like to have one of the variables to have had a positive 1 or a negative 1 coefficient. If I was solving by substitution here, I would end up having to, at some point, if I was solving for one of those x's, here, there we go, like this x, I at some point would have had to divide by 8. Dividing makes fractions. Or here I'd have to divide by negative 5. Dividing makes fractions. So in all of these cases, if I was solving by substitution, dividing would have made fractions. And usually, you don't like fractions. They're harder to work with. So yeah, so that's why elimination method was a great choice for that problem. All right, let's take a look at question 14 a little bit faster this time. So between the x's, to get opposite x's, 10 and negative 2, the least common multiple is 10, right? 10 goes into 10 and 2 goes into 10. The least common multiple between 9 and 3 is 9, because 9 fits into 9 and 3 fits into 9. I'll pick the smaller of the two. What would I have to multiply this equation by to get that to be a 9? Well, it is a 9. That equation's all set. And what would I have to multiply the second equation's y by in order to get that to be 9? 3. Now, should I make that a negative 3? Yeah, this 9 is already negative, so I'm happy to have a positive 9 here. I'll get my opposite coefficient as is. So question 1, or step 1, sorry, multiply through. I'll have negative 6x when I'm distributing here. 3 times 3y is plus 9y. Wonderful. That was what I was shooting for. And 3 times 10 is 30. And for step 2, I'll rewrite that first equation. You don't technically have to, but just be careful. Don't. Be careful. Sometimes setting myself up for success is going to be a whole lot better, less likely to make mistakes. All right, so negative 6x plus 10x. Oh no, guys, the x's don't get eliminated. Is that a problem? No, because I wanted to eliminate the y's this time. So we're fine. We're happy that x is still here. So negative 6x plus 10x is positive 4x. The y's add to be 0y, which is 0, which I don't even have to write. And 30 plus 46, yikes, 76. And these are big number. All right, so for my solve step, how do I solve that for x? How do I get x by itself? I like it. All right, so this is what I'm kind of thinking. Watch my scratch work on the side. So I'm thinking, all right, 76 divided by 4. I don't know. However, I do know 80 divided by 4. That I could do. And think about 76 is the same as just 80 minus 4. You guys agree? Right? And 80 minus 4 all divided by 4 is the same as 80 divided by 4 minus 4 divided by 4. And so this is literally, like, I wouldn't normally write all this down. This is kind of like how I would approach it if I didn't have a calculator and I was out in the wilderness, as I might be, and I'm just, like, solving algebra problems, as, of course, everyone does when they go for a walk in the woods. So let's see, 80 divided by 4, 8 divided by 4 is 2, with a 0 is 20, and 4, oh, sorry, that 4 part there. 4 divided by 4, I must have been, like, mentally thinking, is 1, and I'm subtracting it. 20 minus 1 is positive 19. All right, so I get x equals 19. Yeah, I would not have known that 76 divided by 4 was 19. Not on my list. Not in my data banks. It's not in my random access memory. So, that is only half of our answer. But if x is equal to 19, where should I plug it so that I could find y? Which equation do you like? I technically could also use this equation if I want. I've got 3 places that I could plug 19 in for x. Any of those seem easier than the others? Which one? Third one? This? Yeah, I mean, it could be. I'm going to aim for, you wouldn't be wrong, and actually, I even encourage you could do that out right now if you want. I'm going to plug it into this one just because 2, 3, and 10 seem smaller than those 3 and smaller than those. That's my only reason. That's it. But, like I said, ain't wrong. So, I'm going to plug it into this x right here. So let's see. So for step 4, do this substitution. I'll have negative 2 times 19 plus py equals 10. Negative 2 times 19, well, 2 times 20 is 40, and 2 less than that is 38. And it's negative. Negative 38 plus 3y. If you reached for a calculator there, that's fine. Right, add 38 to both sides. Yellow, scroll it down. 3y equals 48. Divide both sides by 3. Guys, 8 divided by 3. Well, 6 goes into 48 8 times. And 3 goes into 6 twice, so I'd have to double 8. 16. 16? That might not have made any sense. Whenever people do math out loud, I don't know. I understand. So my solution is 19, 6. Which, if I was solving the system by graphing, right, that kind of would have been like far-ish from the origin, or like the intersection of the 2 lines might have been far off my graph, and I've been like, oh man, like I can't find the intersection. I didn't make my grid window big enough. And so, yeah, so it's not, substitution or elimination, super accurate, and they work even when you have larger answers. All right, last question. All right, I got to pick up the pace here. What would you multiply each equation by to get opposite coefficients for one variable? So here's question 18. We're not solving it. We're just oppositing the variables for one of them. Let's see, 8 and 12. Let's find a common multiple between those. So 8, 16, or, ooh, I think I found it. 12, 24. Looks like that's the least common multiple for those. Between 7 and 11, oh man, those are what's called relatively prime to one another. I happen to know that it's just going to be 77. Like, the least common multiple will happen to be the product of 7 and 11. I'd end up having quite a list here. I'm probably going to forget my multiple at some point. Wow. Wow. Did I get there yet? No, I made a mistake somewhere. 49 is definitely right. 6. Oh, 63. That's what it was. All right. Yeah, for some reason I was like 7 minus 6 is 1, and then I made a 1, but that's not at all what works out. There we go, 70 and 77. I told you I was going to make a mistake. And then 11s would have been, right, 11 and 22 and 33, 44, 55, 66, 77. Yeah, so either way. Easier one to work with is clearly the 24. What would I have to multiply this equation by to get 12 to be a 24? 2. 2, right? Might not have enough space to write that. And what would I have to multiply this equation by to get 8 to be a 24? 3. And those both are positive, so one of them would have to be negative. So either this 3 is negative or the 2 is negative. It doesn't matter. So multiplying the first one by 2, the second one by negative 3 would have been impossible. All right. Thanks for watching, Internet friends. Have a great day. Bye-bye.